Today's lesson is on parallel and perpendicular lines. We're going to look at how we can identify them. Okay, I have some notes here. Parallel lines are different lines in the same plane that never intersect. Two non-vertical lines are parallel if they have the same slope and different y-intercepts. So I want you to, sorry about that. I want you to highlight they have the same slope and different y-intercepts. Highlight that, and these are parallel lines. Okay, two lines in a plane are perpendicular if they intersect at right angles. So perpendicular lines, they intersect at right angles. Two non-vertical lines are perpendicular if the product of their slope is -1. So this is the important part. The product of their slope is -1, and they will make right angles. Okay, so those are the important parts of that definition I want you to highlight. Now, we're going to look at two lines, and on each of these lines, the most important thing that we're going to look for is we're going to look for the slope of the line. So if I look at this first equation, it's in y equals mx plus b form. It's already there. So my m is -3, my b is 2. Okay, now I'm going to look at my second line. Is that in slope-intercept form? Y plus 5x is equal to -4. It's not, so I need to put it into slope-intercept form. So I'm going to subtract 5x from this side, and I'm going to place it on the other side so I can get y by itself. So now I have y over here. I'm going to put my x in front because I like it to be y equals mx, and then plus b, or change if I want to. Okay, now I look at this one, I say, okay, my slope now is -5, and my b is -4. Okay, now I look back up to my definition. Do they have the same slope and different y-intercepts? So I look at the slope. Here's the slope here, and here's the slope here. So do they have the same slope and different y-intercept? No. Do they have a product of their slope is -1? So if I look at this, I would know the product of their slope would be -1 if they were flipped over an opposite sign. When we get there, I'm going to prove that to you. So are these two slopes flipped over an opposite sign? Is one the reciprocal of the other an opposite sign? It's not. So therefore, there are two different slopes, and two different slopes are intersecting. So these lines just intersect. Nothing special about them, they just cross. So intersecting lines would be something like this. Just an intersecting point, and they intersect in that very middle point. Okay, let's look at the next one. So as we get to the different examples, we'll kind of elaborate on what that means. Okay, the next one. Is this in slope-intercept form? Y equals mx plus b. It is, so my m for the first one is 1. My b is 8. Okay, now I look at the next line. Is this one in slope-intercept form? It looks like it's x minus y is equal to -1. So it's not in slope-intercept form. I'm going to move the x to the other side by taking the opposite. Okay, I still have -y over here. This becomes -x and a -1. I'm going to divide by -1 because I can't have a -x. I want -y. I want a positive y, so I'm going to divide everything by -1, everything I see. So this becomes positive y, negative and negative is positive x, and negative and negative is positive 1. Okay, so now my slope here, my slope is 1, and my b is also 1. Okay, so now let's highlight this. My slope is 1 here, and my slope is 1 down here. So now do they have the same slope? They do, they have the same slope. Do they have different y-intercepts? This y-intercept is 8, this y-intercept is 1, so they do. So therefore, this line is parallel. Okay, now I'm going to look at this third line here. There's 2 lines, and is this in slope-intercept form? It's not, so I'm going to do a little bit of work over here so I have a little bit more space. I have 2x minus 5y is equal to negative 3. I need to move it so that I have y by itself, so I'm going to subtract 2x from both sides. I still have negative 5y. I'm going to put the negative 2x in the front, and I'm going to keep the negative 3. I'm going to divide, I'll change my color for this final step. I'm going to divide everything I see by negative 5, negative 5, and negative 5. Okay, so I've got just one y here. Negative and negative is a positive 2 over 5, and that's an x. Negative negative is positive 3 over 5. Okay, so I've got my m is 2 over 5. My b is 3 over 5. Okay, so that's the first one. Now the second line, I'm going to go ahead and use red. I have 5x plus 2y is equal to 6. It's not in slope-intercept form, so I need to do a little bit of work to get it there. I'm going to subtract 5x from both sides. I have 2y. I like to bring my x in front, so it's negative 5x plus 6, because that's a positive 6. Change my cyan color right here. I'll divide by negative 2, negative 2, and negative 2. This becomes a positive y. Negative and positive is a negative 5 over 2. X plus 3. Okay, so now my slope for this one is, my slope is negative 5 over 2. My b is 3. Okay, then I go through and I ask myself, okay, do they have the same slope? And I'm going to highlight our slope. Do they have the same slope? Well, this slope is 5 over 2, or 2 over 5 rather, and this slope down here is negative 5 over 2. Alright, so it's not the same slope. Are they perpendicular? Is the product of their slopes negative 1? And let's see. This is where we're going to prove that these are perpendicular lines. So I am going to, let me see the color I haven't used. Choose gray. Okay, I'm going to take, if I can find my cursor, and I've got 2 over 5 times negative 5 over 2. When I multiply that together, I can multiply and make this a negative 10, and this a positive 10. Negative and negative, or negative and positive is negative. 10 over 10 is 1. Or maybe you're more comfortable with cross-canceling. I can cancel the 2 and the 2. They become 1s. The 5 and the 5, they become 1s. So 1 times negative 1 is negative 1. And then 1 times 1 is 1. So this has a value of negative 1 when you multiply it. So therefore, this third one is perpendicular. This line is perpendicular. And a quick way, so you don't have to do all the multiplication, is if you look at the sign, the slope, and if it's flipped over, opposite sign, they're perpendicular. So 2 over 5, 5 over 2, and 1's negative, then it's a perpendicular line, so you don't have to go through all the proving of it. Okay, next one. Okay, now let's do number 4. And is this in slope-intercept form? It is. My slope is 3, and my b is 2. So I like it when it's already in slope-intercept form, no work to do. Okay, the second one, is this in slope-intercept form? It's not, so I need to move the negative 6x to the other side by adding 6x to both sides. I have 2y. I like my x in front, so I'm going to bring my 6x forward, and negative 8. I'm going to divide by 2 everything I see. So now I have y is equal to 2 will go into 6 3 times, 3x. 2 will go into negative 8, negative 4 times. So my slope on this equation is 3, and my b is negative 4. So again, look at the slope. That's your starting place. This is a 3, and this is a 3. So what do we know if they have the same slope? As long as they have different y-intercepts, then that line is parallel. Okay, so number 4 was parallel. Number 5. Again, the first one's easy. My slope is negative 4. My b is 8. Oh, the next one's also in slope-intercept. My m is 1, is it 4th or 1/2? Anyways, oh, it's 1/4, and my b is 7. Okay, so now let's look at the slopes. Okay, negative 1, 4 over 1, and 1 over 4. So I've got negative 4 over 1, and then I have 1 over 4. So what do we see about these slopes? They're flipped over, opposite sign, so therefore this one is a perpendicular line. I like that one, not a lot of work for it. Okay, and now these two. One is a 0 slope, and one is a no slope loop. So therefore, these are intersecting lines. And we're just going to call it they cross. Alright, they're intersecting lines. Alright, the last 7, 8, 9, and 10, we are only going to have to find the slope of the 2 points. So now we have line P1 and line P2. We're going to do rack them, stack them, subtract them. We're going to find out what the slope is. If they have the same slope, they're parallel lines. If they have totally different slopes, they're intersecting lines. And if they have flipped over opposite sign, then they're perpendicular. So we're going to rack them up. We're going to stack them. So we've got 3, negative 6, negative 4, and 1. Do the math, keep this, change, change. At the top we have a positive 9. Keep, change, change. At the bottom we have a negative 5. So that's our first slope right here. I'm going to box it. Use a different color for the next one. We have Q1 and Q2. So we're going to rack them up. We're going to stack them. So I have negative 3 and 6 and 0 and 5. Remember, the y's go on top and the x's go on the bottom. So we're going to keep, change, change, and I get a negative 9. And I'm going to keep, change, change, and I get a negative 5. Two negatives make a positive 9 over 5. Here's the second slope that we made. Oop. Oh, let me fix that. It's writing all over the top of it. Okay, so we got 9 over 5, and it's positive. Okay, now, are they the same slope? No, one's positive, one's negative. Are they flipped over opposite sign? Or they take the reciprocal and the signs are opposite? No, they're exactly the same. The 9's still on the top, the 5 is still on the bottom. So therefore, this answer is just intersecting. So it's just an intersecting line. Alright? Okay, I'm going to erase my work so we can look at the next one. I have a little bit more to erase here. Okay, now we're going to do the same thing with these 4 order pairs. We're going to make them, and we're going to find out what the slope is of the line. So we're going to rack them, stack them, subtract them. So I've got 3 and a negative 6 and a 5 and a negative 10. I'm going to draw my division bar. My y's go on top, so it's negative 6, negative 10. My x's go on the bottom. It's 3 and 5. Okay, then we're going to do keep, change, change. So at the top here, I have 10 minus 6 is 4, and it's positive. Keep, change, change, and I get 5 minus 3 is 2, and it's negative 2. Negative 2 will go into positive 4, negative 2 times. Okay, that's my P line. So it's the slope of P. Okay, the next one, we've got Q. So here's Q, the slope of Q. So MQ, I guess. We got 4 and negative 5. And we got 0 and 3. I'm going to draw my fraction bar, put my subtraction sign in there. The y's go on top, so it's negative 5 and 3. And then the x's go on the bottom. It's 4 and 0. So we're going to go keep, change, change, keep, change, change. I get negative 8. And then 4 minus 0 is 4. 4 will go into negative 8, negative 2 times. So my slope of the first line is negative 2. My slope of the second line is negative 2. Same slope. This is a parallel line. Same slope, different y-intercepts, so they're parallel lines. Okay, let's go to the next one. We're going to go down. Okay, we're going to go through and do rack them, stack them, subtract them. So we're going to do one more, and then the last one you're going to do by yourself, and you're going to check your work with it. Okay, we got negative 1 and 0 and 1 and 4. Okay, rack them up. Put my line, put my negative signs in between. We got 0, 4, negative 1, and 1. So I've got keep, change, change, which is negative 4. Keep, change, change, which is negative 2. And I get negative 2 will go into negative 4, positive 2 times. Then we're going to do this line right here. So now I've got negative 5 and negative 8, negative 3, and negative 9. Draw them, rack them up, rack them. Now we're stacking them. and we're going to subtract them. Okay, y is in the top, x is in the bottom. And I'm just plugging in the numbers they gave me. Okay, now we're going to do keep, change, change. We get a +1. Keep, change, change, and I get a -2. Okay, so I've got my slopes here. I have a 2 and a 1/2 negative. Okay, can I make this a fraction by putting a 1 under it? I can. So now are they opposites? Do I have 2/1? 1/2? One's negative, one's positive. This is a perpendicular line. Alright, and the last one, I want you to try it by yourself. I'm going to stop, do the work, and then I'll just turn it back on to give you the answers. So do it yourself. Okay, and finally number 10, hopefully you did the work. I did my work and I found out I had a 0 slope for line P, and I found out I had a 0 slope for line Q. So therefore they have the same slope, so it's parallel lines. Alright, so that is the introduction to parallel lines.